What is going on, coders? Welcome to this Python 3 video on solid design principles. In this video, we're going to take a look at the Liskov substitution principle, or the L in the solid acronym. Now, you might be wondering what the Liskov substitution principle actually is. Well, I've put a little definition here, and it's a derived class can assume the place of its superclass and everything should work. Alright, that sounds a little bit cryptic, I know. So ultimately I've devised a little example for us which should demonstrate exactly what this definition means. Now, in this scenario, we're going to be writing some methods and some classes that will allow a robot that our friend has built to walk into the kitchen and start turning on and turning off kitchen appliances. So let's take a look at the code for this. So we're going to have a class called kitchen appliance, like that. And in this class, we're going to have the on method, and we're just going to say pass for now, and we're going to have the off method. We're just going to say pass, and then we're going to have a set temperature method. I'm going to pass. Alright, and let's say that we want our robot to be able to turn on and turn off the toaster. So we're going to have a class called toaster, and this class is going to inherit from kitchen appliance like so, and it's going to pretty much implement all of those methods in practice. So we're just going to have some code to turn on toaster, and then we're gonna have some code to turn off that toaster, and then finally some code to set temp on toaster. Alright, so this is pretty simple example. We can turn on, turn off, and set the temperature on the toaster, and you can easily replace the toaster with like an oven or whatever. So that's all good. This is so far so good. We're not breaking the Liskov substitution principle in any way. However, if we take a look at another kitchen appliance, which is the juicer. So like making orange juice, and you want your robot to be able to turn on and turn off the juicer. So you're gonna have a class called juicer, and that's gonna inherit from kitchen appliance, and we're gonna have all of these methods again: turn on juicer, turn off juicer, and set temperature on juicer. But wait, the juicer doesn't actually have a set temperature setting. The juicer does not regulate the temperature at which it juices. So what we need to do is actually, you might think, well, actually we don't define that method, it doesn't have it. And you would be correct, but actually you would also be very wrong when it comes down to the Liskov substitution principle. And why is that, you might wonder? Well, essentially, any derived class should be able to implement the superclass methods that are available to us. So if we make a mistake on our code, or we're writing some tests, we can't actually ignore the fact that this juicer inherits from kitchen appliance, and it's actually able to implement or call the set temperature method. But the set temperature method, or the set temperature ability, does not exist on a juicer. So what is that going to do? Well, actually it's going to throw a massive, huge, monstrous error in our application, and we're gonna like go in panic because our robot is going crazy in the kitchen. All right, so we can't have that. So what we need to do is we need to start from scratch. All right, we've broken the Liskov substitution principle by having the ability to call this set temperature method. So we need to start over and see how we can redefine all of this. Okay, so first off, we're gonna have the same kitchen appliance start with the on and off methods. And then what we could do is we can say we're going to have a kitchen appliance with temperature. All right, and that's gonna inherit from kitchen appliance like that. And then what we can do is we're gonna have a set temperature method in here. Okay, we're just gonna say pass for now. Okay, so what does that look like in the original example? Well, when we go into class called toaster, when we create that class, what we can do is we can inherit from the kitchen appliance with temp, and then we can re-implement those three methods, like set temperature and set temp on toaster. All right, and in here we can just have turn off toaster, and then we can have a turn on toaster. All right, so this is all good. Now, if you recall, we didn't actually break the Liskov substitution principle with the toaster, we broke it with the juicer. So what does that look like? Well, we're gonna have a class called juicer, and then what that class is going to do is it's actually going to be based on the kitchen appliance. All right, and then we can just do a on for the juicer method and off for the juicer method, like that. And essentially now, during our testing, we can't actually call the set temperature because it doesn't exist, but actually we're not deriving from a class, so we're all good. So this is the correct implementation and structure for our kitchen appliances and our little robot, which can deal with the toaster, deal with the juicer, and not break the principle itself. All right, so that's pretty much it for this video. I hope it's been useful, and please do give me any comments in the comments section down below about the quality of the video, about the kind of speed, and also if you've got any comments or questions on the code, please provide them. This is all very useful feedback for me. So thank you for watching, and I will see you in the next video.